In this video, you are going to learn the general concept of enthalpy. Now, let's look at this case. If you have a piston in this cylinder, so here you have a piston, and this piston is free to move left to right. Let's say over here is frictionless. Let's say over here is also frictionless. What I'm going to do is I'm going to put a candle over here to heat it up. So when I do that, I will apply heat to the system. So what will happen over here? There are two things that may happen. The first thing is when you heat it up, it might get hot. That is the first thing. The second thing is when you heat it up, if we allow the piston to move to the right side, so it's also moving in this direction. So those are the two things that will change. Let's talk a little bit about pressure. For example, if you want to put this piece of sharp material into your thumb, for example, here's your thumb over here, and if you push in, how can you get this little nail get into the skin? There are two ways. You can either increase the force or you can make it sharper. That means reduce the area. So you can either increase the force, let me put it pointing up, increase the force or reduce the area. In other words, we want to have a higher pressure so it can get into the skin. Okay, so pressure is defined as force divided by area. At the same time, if we push this one to this side, so what happens is work will be equal to force times the length that it travels. So that is the definition of mechanical work. From this equation here, we can see force is equal to pressure times area, and therefore work will be equal to force is pressure times area and force times distance. So we also times distance here. If we combine this together, we can see that this one, it is area times distance. That means it's the area of the piston times the area it can move, and therefore is P times V. So what I'm trying to say is, when we apply heat to this system, we can have two things may happen. One is the temperature will increase. Temperature will increase. So now I'm going to introduce a new term, U, that is the internal energy. Internal energy. And internal energy is a function of temperature. The next one is when we put heat into it, not only that the temperature will increase, but we also can push the piston to the right side. And therefore, when I put heat into the system, I can have increased the internal energy, and I can also do some work, which is P plus V. And we just describe how we get P times V, because we get the pressure and it push it to the right side. And when it moves to the next position, then we have the increase in volume in this case. So let's remember this. We are going to write this down, draw this down now. Q, that is equal to internal energy plus P times V, where this is the work. Okay, let's get back over here. Now, I'm going to give you a definition of enthalpy. Enthalpy is a new term over here that is equal to the internal energy plus PV. This is just a definition. That means, look at what we had before. Before, when we apply heat to the system, what we get is it can increase the temperature and or you change the position of the piston so that it's doing work. In this case, look at it. So enthalpy in this case, enthalpy is the same as heat. Under what condition? Let's look back here. Because we say that this piston is free to move. It doesn't have any friction. What does that mean? That means the pressure on the left side here will be equal to the pressure outside here. Which means under some condition, under this condition, under constant pressure, when it is constant pressure, then enthalpy is same as the heat. And by the way, most of the time for the chemical reaction, it happens under a constant pressure, which is 1 atmosphere. Because it's open to the atmosphere, that means whatever experiment we are doing is under the constant pressure. Okay, so under constant pressure, enthalpy is same as the heat. In general, when we see a chemical reaction, for example, if we say A plus B, substance A plus substance B, or reactant A react with reactant B is going to yield, for example, C. And sometimes over here, we are going to say what is the change of the enthalpy or of the heat. For example, if I say enthalpy change, I'm going to use the word delta H. Let's say delta H is equal to 125 joule per mole. That means when 1 mole of this to react, that means 1 mole, just for 1 mole over here, okay, or just for this equation over here, is going to absorb 125 joules. Let's look at this one. When delta H is a positive number, what does it mean? I'm going to draw the diagram over here. Initially, so let's say this, I'm plotting energy versus reactant and product. Let's say this is initial. That means the reactant is here. When it absorbs the heat, and now this is a product or final. What happened here? When delta H is positive, see from here to here, so final minus initial is positive. That means it absorbs the heat. That means it is endothermic. Let me put it this way. Let's say our reactant initially is over here, and finally, in the final product, it is over here. So what is my delta H? Delta H is equal to final enthalpy minus initial enthalpy. So delta H here, it is negative. That is exothermic. Exothermic. Let me repeat that again. When delta H is positive, that means it's greater than 0. That means the process or the reaction, it is endothermic. Endothermic. When delta H is negative, that means the reaction is exothermic.